Okay, so let's look at the Chapter 4 Review B, numbers 2, 3, and 4. So CPCTC stands for corresponding parts of congruent triangles are congruent. You can use it in a proof. Ooh, looks like I crossed that off. Meant to underline it. You can use it in a proof. Use after you have congruent triangles. And what kind of statements have it as the reason? Well, if CPCTC is your reason, then the statements could be one of two things. It could be a side congruent to a side, or an angle congruent to an angle. In number 3, what are the 4 main ways of proving triangles congruent? Well, there's SSS, there's SAS, there's ASA, and there's AAS, which is the same as SAA. Now, actually, we mentioned one other thing in class. It turns out that this one doesn't work for most triangles, but it only works for right triangles. So if you ever see something where that comes up, feel free to use it. It's not a requirement to know this for the test. You can get through the test without knowing it, but if you remember it, I'm not sure, but maybe it comes up somewhere and it might be handy. So in general, we don't include this one. Okay, so number 4 here is a proof that involves some of these triangles over here. In this one, we know we're going to aim for BCD, which is this triangle, being congruent to another one, and you can probably guess pretty easily we're going to aim for the other big one right here. So if I went BCD, I went along the long side and then the short side, so I'm going to do the same thing here, DEB. So let's look at our givens. BC congruent to ED, that actually helps with the 2 blue triangles. And BE congruent to CD also helps with those 2 big triangles. So I'm going to list those off. BC congruent to ED and BE congruent to CD. These are both given. Now the one other thing that I could easily match up between these 2 triangles is this big blue side right here, BD. So that has to go with itself. That's reflexive. And if you look at those 2 big blue triangles, I now have side, side, side. Okay, so now the question is, how do I get to step 7? Step 7 here says BCY. So BCY is this triangle. So the question is, why is that triangle going to be congruent to, and you can probably guess that this is the triangle we're going to try and match it up with. So if I went BCY, I went long side and then cut inside. And so that's going to go with D long side and then cut in, so DEX. So DEX here. Okay, so how do I prove that those are the same? Well, one nice thing is these are already matched up. So really, BC congruent to ED helped me prove these triangles are congruent, and it's also going to help me prove these triangles are congruent. I do have another given, 1 congruent to 2, so that actually helps with the red triangles. So I'm going to put that here next to the one that's already filled in as given. And so now let's go back to what we were looking at before. We were looking at this. We had 2 triangles congruent because of SSS. Those were the 2 big blue triangles here. So something about the blue triangles, we know we're always going to follow congruent triangles with CPCTC. So something about the blue triangles has to help me with the red triangles. And if you look at what they share, well, I keep using green. They share that angle right there. Right? The red and the blue have that angle in common. And the corresponding one down here is that one. So that's what they share. So I can actually say here, if I just number this 3 and 4, I can say angle 3 is congruent to angle 4 because they're corresponding parts of my blue congruent triangles, so they're congruent. And the nice thing is that they're also in the red triangles, so now I can use them to help me prove the congruent red triangles. Okay. Going back to the red. Now, if you look at the red triangles, I already have angle, side, angle, right? And the same deal going this way, angle, side, angle. So I have ASA. All right. Well, now the goal is to prove this. XE is parallel to YC. And so the ways to get parallel lines, they all end with give you parallel lines. And there are 5 ways. The common ones have been corresponding angles are congruent, alternate interior angles are congruent. And let's highlight the lines that we're trying to prove are parallel. So XE is this one here, and CY is this one here. And you can kind of see that this forms a transversal going right down the middle. So if I extend those just a little bit, you can see it a little bit better. Okay, so we just got to the red triangles are congruent, and we're going to follow that up with CP/CTC. So the question is, what about the red triangles help me get parallel lines? Well, if you look right here at that angle and that angle, those are matching parts of the red triangles. And if I can prove those are congruent, well, those form alternate interior angles. So I'm going to say here, I'll just number these two, 5 and 6. Angle 5 is congruent to angle 6 because of CP/CTC, and those angles form alternate interior angles that are congruent. So they give me my parallel lines.